Welcome back. So in this video we are going to use support vector machine, and we also consider the other algorithms such as the RandomForestClassifier and the KNeighborsClassifier, and also we will also touch on what is called the multilayer perception. So let's start with the support vector machine. All right, so I'm going to actually import the support vector machine from scikit-learn. Alright, so from scikit-learn.svm, I'm going to import what is called the SVC, alright, which is support vector classifier, and then I'll initialize it. Remember, previously we started with classifier, so in this case, to differentiate, I'll just use what is called SVC underscore classifier. Alright, I'll use what is called SVC underscore classifier, and then this will be equal to our SVC. Alright, and we're going to use different hyperparameters with regards to support vector machine. So the first one that we're going to use is kernel. Kernel equals linear. Right, you're going to use linear, which assumes that with whatever classes that we're working on, it can be separated linearly. And if you're not quite familiar with this, I suggest you just take a pause here and then check out the documentary. Right, if you go to the support vector, the scikit-learn.svm.svc, you can see all the various parameters that we can use and the explanation to each of them. All right, so you can take a pause here and then just have a little bit, a brief about it. So here I'm using kernel. All right, I'm using kernel here. See, kernel, we have kernel default to be RBF, and I'm going to use linear, which assumes that we can actually separate our data linearly. All right, and so you can just have a little bit readings here. All right, so going back, I'm going to use this initialization here, which will become my model. All right, then I'll use it to fit on the X train. All right, on the X train, and also on the Y train. All right, so that's it. This is where the learning starts. All right, and the same way as we did for this and get to the accuracy scores, I'm going to use the same thing over here. All right, I'm going to use the same thing over here. So I'm going to actually copy this. Let me copy everything here, so that when I go down here, I'll make the modification here. Okay, so I'm going to do that. And then this, I can actually name it as SVM. All right, so that it will differentiate it. It will not go and override this accuracy that I have previously. So SVM underscore accuracy equals cross-val score, the same thing over here. And then for this classifier, remember we've named it as SVM classifier. So I'm going to change that. All right, and then that's it, we're done. And over here is supposed to be this SVM. Oh, no, it's supposed to be this, right? This is the accuracy, so I'm going to print this one here. All right, so if we run this, let's see what happened. Kernel, not kernel. Kernel. Yeah, so now you can see that with different folds, right? With different folds, now we're having different accuracies. We have 10 different folds here, right? So that is why I said just take a moment and then see what this fold mean. Right, it's just nothing but just dividing our data set into 10 different folds, and then using say 9 of them for training, and then using 10 for testing. All right, so it will do that 10 times, and then it will just divide our data into 10 different folds, and then do that, and then give us the accuracy for each of them that it will do here. All right, and then what we can do is to find the mean of this, so that we will have a better idea. So just like we did for this, I'm going to do the same thing for support vector machine, and this is SVM accuracies. All right, so I'm going to find the mean for this, and you can see that the mean is 98%. All right, like 99 if you want to run it. All right, so let's compare that one to our logistic regression. Our logistic is also making 98%. All right, so quite on the same scale. All right, and if we want to also check this prediction, we can also do the same thing over here. All right, we can do the same thing over here. So with this classifier, now we name it as SVM classifier. So I'm going to use that, then make some predictions and save it into SVM classifier predictions. All right, so over here I'm going to print this as, make it SVM, not SVM. I think this is better. Okay, now you can see that we're making some predictions over here. All right, with respect to SVM underscore predictions. All right, so you can see that it's almost making the same predictions, 101 1000. All right, as you can see over here, 101 100. All right, so it's making almost the same predictions as that's why we have almost the same accuracy. All right, we can also do confusion matrix for this. So I'm going to use the same thing, not with the package. We've loaded it, so it's unnecessary to load it again. And then over here, I'm going to just change this prediction, and then use the SVM prediction over here. All right, and then what else? This, okay, this is done. This is done. What else would I change? That's it. Now if we run this, now we can see over here, at first you can see that this one was for zeros, it was predicting 150 of them as right. We predicted 150 zeros as zeros, and then we wrongly predicted 6 of the zeros as 1. All right, but in this case we are predicting 152, right, like 152 of them as zeros, and then I mean 150 actually as zeros, and then only 4 we are making a mistake, all right, predicting zeros as 1. And then you can see that only one of the ones that we are wrongly predicting as 0. All right, just like this one is also doing. Okay, so let's move on and do the same thing for let me leave one space here, and then we can actually change, instead of using kernel equals linear, now I'm going to use kernel equals RBF. So I'm going to do the same thing, but this time I'm going to change this linear to RBF. All right, so this is just hyperparameter tuning that I'm doing over here. All right, so instead of SVM classifier, I can do it RBF classifier. All right, and then I'll do this RBF classifier, come here, do RBF, and then over here I'll do RBF accuracies. Then I'll get the RBF accuracies. All right, so the same thing, but I'm just hyper tuning the parameter in the support vector classifier. All right, and then see the results that I'll get. Now this one is actually performing better than the other one. All right, it's actually making 100% accuracies. All right, unlike this one, which is making 99, 99, 99, 99, but this one is actually making 100%, which is quite weird and quite unusual. It doesn't actually normally happen for your algorithm to perform 100%. All right, so we can move on by also doing some predictions. All right, by doing some, if we check the mean, it's actually going to give us 1. All right, so maybe there's no need to do that, but you can actually do that. But if you check the mean, it's actually going to give you 1. And over here we can make some predictions. So I'm going to change the SVM to RBF. All right, RBF. This is RBF classifier. Okay, so let's see. Now you can see the predictions that is making here. Now the confusion matrix will actually make it a bit clear for us to see how many mistakes that is making. But in this case, since it's making 100% accuracy, it means that it's not going to make any mistakes over there. All right, so this is actually RBF, and I think that is all we need to change. Okay, now if we see this, now you can see over here, right, 160 of the zeros we were able to predict as 0, and then none of them, we did no mistake here, and then 120 of the ones we were able to predict as 1, and we made no mistake here. All right, that's why we have an accuracy of 1, accuracy of 1 or 100%. all right, so let me leave this space, and then we can also start by building what is called the random forest classifier. So let me convert this. Let me actually convert this to a markdown, and then let me write it over here. Random forest classifier. All right. So the same way I'm going to actually get it from scikit-learn. Oh, come on. From sklearn, all right. .ensemble. I'm going to import random forest. I don't want to type this. Okay. I'm going to import random forest. So let me run that and see if things are working fine. .ensemble, no model named ensemble. I know I make spelling mistakes here. Okay, now cool. So random forest, all right, so you see that we are using SVM, RBF, just a short form of whatever model that we are building, so that we get to know it, right? So in this case, I'm just going to shorten it to RFC, right? I think that will do. Random forest, right? So maybe RFC, random forest classifier. So RFC underscore classifier. All right. So all I'm going to do is initializing this. All right. And then there's something called the N estimator, right? That is the number of estimators. And I'm going to set that to say 50. Then I'm going to decide the criterion. And I'm going to say that use entropy. As I said, if you're not familiar with any of these, it's not a problem. Just read a little about it in the documentary, and you can easily get it. It's not anything big, you can easily get it. All these are just hyperparameters that you can tune to get to the best accuracies. All right. So if you're using a particular model and it's not performing, it's not that you have to just change the algorithm. You can also tune the parameters so that they will actually work well for you. Maybe what you're using is not actually working with respect to your data set. All right, so you can actually tune that. So let me move ahead and then use that to learn. All right, so I'm going to use fit and then make it learn from the X train. The Y train. All right, So that's it for here. And maybe I should do this one. I don't want to write it over and over again. I can easily get it and then make changes in that. All right, so instead of RBF, now I'm using RFC. Okay, and then I'm using RFC classifier. All right, all good. Okay, so now if we do this, we have double R here, unexpected keyword and estimator. Okay, we miss S. Estimate this criterion. Okay, now you can see that we have different accuracies here, right? Some being 100%, some being 99. All right, so we can actually find the mean of these. All right, we can actually find the mean of these 10 different accuracies that we have over here. So I'm just going to use the same thing that we used earlier on. All right, to get to the mean of it, I'm going to use the same thing. All right, so in this case we have RCF accuracy. Maybe I should just delete this one, RC. All right, and if I do that, we have 99.5, right? 99.5% over here for random forest. All right, let me make this a bit bolder. Okay, for random forest we have 99%. So we can also do confusion matrix for it, so that visually we can actually see the mistakes that it's doing. All right, so for here we have RFC, so maybe just this, that, and then it's done. RFC underscore classifier. Okay, we did not do predictions before. Let me do this, and then we will do predictions. All right, so we will do RFC predictions. We will use RFC classifier. Okay, now if we run this, cool, it's making predictions for us. Now I'm going to use that over here. I think it's the same thing, I don't need to change it. So now if I run it, now it's working for us. All right, now we have a beautiful confusion matrix here. Now we can actually see from here that we have 160, right? 160. 160 of the zeros. Let me push it a bit up first to actually see. All right. Okay, now we can see that we have 160 of the zeros we were able to predict as 0. All right, and only one of it that was wrongly predicted as 1 instead of 0. All right, and then for the ones, we were actually able to predict 120 of them as 1, and only I mean we did not actually make any mistakes over there. All right, and that's why we have a high accuracy as we're having a high accuracy. Let me go a little bit up. All right, we're having a high accuracy as high as 99%. All right, so let's also try a different algorithm. Let's try the KNeighborsClassifier. So we are trying different classification models to see the performance of each. All right.